Hello guys, welcome back to the Maths Club. I know it's been a while. I have not posted on my social media handles. Actually, I took out time to handle some personal issues. But I promise you guys, you are going to be getting back-to-back content in mathematics from my end. So today, I want to answer a question from one of my subscribers on YouTube who sent me a question that is the Indian CBSE mathematics question of 2024. So let's go directly into the question. If you are not following me, know that you will be missing a lot of content in the days ahead because I'm going to be posting back to back interesting content in mathematics, content that are going to really enlighten our understanding in mathematics. So you can share my videos, comment, like to encourage the Maths Club page. So, ladies and gentlemen, let's go into the question. Now we are given this equation and we are asked to find dy dx. We are told that cos x exponent y equal to cos y exponent x, and we are asked to find dy dx. That's the first derivative. So the first thing we do there will be for us to take logarithm on both sides. The question is, what type of logarithm are we going to take on both sides? We can either take natural logarithm or we can take logarithm to base 10. If you take logarithm to base 10, it's going to lead to a very complicated solution. So the easier solution is to take logarithm to base e, that's the natural logarithm. So taking natural logarithm on both sides, we are going to have ln cos x exponent y equal to ln cos y exponent x. So according to the law of logarithm, the exponent can go behind your natural logarithm, so that we have y ln cos x equal to, same here, the exponent goes behind the logarithm. We have x ln cos y. So what we actually do is to differentiate. This is a product. If you look at it closely, it is a product. So what I would do is to differentiate y first. Then I keep this one without differentiating. Then secondly, I keep y, then I differentiate this one second. I will do the same here. I will differentiate x first. I keep ln cos y without differentiating. Then later on, I keep x, then I differentiate this one second. So that is applying the product rule. There's no need using substitution. You can just apply the product rule directly in order to gain time. So applying our differentiation directly, differentiating y first. The differential of y with respect to x is actually dy on dx times ln cos x. If you see, I have not differentiated ln cos x, plus I differentiate now, I keep y now. That's why you see x, I mark x on y. The second time that I'm differentiating, I differentiate ln cos x. So I have y. What is the differential of ln cos x? And each time you are differentiating natural logarithm, just differentiate the function in front of your natural logarithm. So what is the differential of cos x? Is negative sine x divided by the function itself, which is cos x. So in essence, each time you are differentiating natural logarithm, differentiate the function in front, which will give us negative sine x, all that divided by the same function in front, which is cos x. So I will apply the same thing here. I differentiate x first. The differential of x is 1 times ln cos y, plus I keep x now. That's why you see I mark x here. I mark a red bar to show that I keep x, differentiate ln cos y. Like I said, you differentiate the function in front of your natural logarithm, which is cos y. The differential is negative sine y divided by the function itself, which is cos y. But since this variable is y, it is not x, we have to multiply it by dy on dx. So each time you are differentiating y with respect to x, you must add dy dx. Take note of that, because this is not cos x, it is cos y, so you have to multiply by dy dx behind. So if we look at it now, we already have on the left hand side, look at my equal sign. On the left hand side, I have dy on dx ln cos x minus y. This minus, I have a minus here because of this minus that I see in this bracket. Sin x all over cos x is tan x equal 1 multiplied by all this is ln cos y. Then this negative, positive x multiplied by this is negative x. Sin y all over cos y is tan y dy on dx. So this implies dy on dx ln of cos x minus y tan x actually equal to, so I'm just rewriting it so that it can be clearer, equal to ln of cos y minus x tan y. So I need space because of space, so minus x tan y dy, oh la la. So dy, oh, is this dy on dx. Okay, so we are actually looking for dy dx. So I will carry the term in dy dx on one side and any term that does not contain dy dx on the other side. So I'm going to have dy dx is here, so I have dy on dx ln of cos x. So this term goes this way, plus x tan y dy on dx. All that should be equal to, I have on this other side ln of cos y, I take this term also to the right hand side since it does not contain dy dx, plus y tan x. So from there now I can factor out dy dx, so I'll have dy on dx into ln of cos x, so let me use a bigger base, plus x tan y should be equal to ln of cos y plus y tan x. Now you see that from here I can make dy dx the subject of formula, so I'll have dy on dx will actually be equal to ln of cos y plus y tan x, all that divided by ln of cos x plus x tan y, which is actually the derivative that we are looking for. Actually, this my subscriber sent me 2 questions, so because of time I have done the first part. Watch out for my next video, because I'm going to be answering the second part of the question. So follow me, like my videos, share and comment. Let's exchange ideas together. See you next.